So guys, next we are excited to welcome PrithviRaj, Casey and Rajani, DevOps engineer from Global Logic. They will they will be discussing how eBPF is transforming Kubernetes networking and security, enabling efficient traffic handling, dynamic policy enforcement, and real-time threat detection. So let's give a warm welcome to PrithviRaj, Casey and Rajani.
Okay, so hi guys, good afternoon to all of you. I know we all had that amazing lunch and just try not to sleep. So so I'm back. So the topic of today's session is what's the role of eBPF in Kubernetes security and networking. Okay, so we'll take a deep dive into what exactly eBPF is and how exactly it's going to affect the Kubernetes security and networking, and also we'll see some part of the observability too. Okay. So before moving forward, I would like to give a brief intro of myself. So my name is Rajani. I work as a DevOps engineer in an MNC that is basically called as Global Logic. And apart from that, I am also a WTM ambassador, Women Tech Makers ambassador. Recently, I got this opportunity to be an ambassador and like do some work for women in tech and women in like DevOps and stuff. And like I guess 2 days before only I got to know that like I was selected as a Docker captain too. So that 2 days only before that happened. Thank you. And this was about myself. I'll give mic to Prithvi so that he can give his intro.
Hello all, I am PrithviRaj. I am working as a DevOps engineer at Mercedes-Benz. So I am triple certified in Kubernetes and triple certified in Azure. So basically working in Kubernetes is my bread and butter. So over to you, Raj.
Okay, so this is gonna be the agenda. So first thing we'll discuss about is the history. Like what is the history behind eBPF coming into the picture? Then we have what exactly is eBPF. Then we have the architecture. We'll see the architecture, like what are the various important components that we have in the architecture. Then what exactly is the role of eBPF now? Like after seeing what is eBPF, we'll see what's the role in networking and security compared considering Kubernetes in the picture. Then we have challenges, like what are some challenges that a beginner or a person who is having experience and they are kind of trying to explore eBPF. So what are some of the challenges that they can explore, that we'll see. Then we have best practices. Then we have some of the examples, and later on at the last part of the session, we'll be having a demonstration. So, okay. So what exactly is eBPF now? So eBPF, we can say it's a technology that is kind of giving you a privilege, like you can write your own programs and you can merge these programs into the kernel level only. Like directly into the kernel level, you can write the programs manually and you can put those programs in the kernel level. And this also without affecting the main source code that you have of your kernel, okay? So there won't be any need for you to go and make any updations in the source code, main source code, and also there won't be any need to kind of performing any kind of reboot operation or loading the modules that we are having. Like there won't be any need. You just have to write the programs, take the programs, and directly use those programs into the kernel level only. So this technology is basically eBPF. So long form of eBPF, we can say it's extended Berkeley Packet Filtering. So talking about the history, so it was developed early in the 90s. So the main motto here was to kind of capture the packets, we can say. And it was again like the main thing that we can say is it used to use the low level programming language. So that was very powerful that they were using the low level programming language, but it was having some kind of drawbacks, we can say. Like it used to take some more time as compared to like how the time that we are taking now. So as compared to this, they used to take more time to write those complex programming programs, we can say. So this was the history. But now like we evolved into, we like brought more things into eBPF, we can say. Like right now, like we are not only doing the packet filtration work, but also when it comes to like enhanced security, we can say. And we have kind of evolved in as compared to the observability too. Like it's very easy now to get some real life like reports into the observability too. Also, like unlike the history, like we used to write all the programs in low level programming languages, But right now we can write these programs in C language. So that's again gonna be very easy to write the programs too. So this was about eBPF. Then we have the architecture. Like these are the four most important components we can say we are having for eBPF. So first one is eBPF program. So this is the most important part we can say. Like you just have to, based on your use case, based on your requirement, you just have to write the program that you have, and that programs will be executed in the kernel level only. That will basically follow the JIT method, that is just-in-time methodology. So you just have to write the programs, merge these programs directly into the kernel level, and you are all ready. Then we have kernel virtual machines. So kernel virtual machines will basically will give you an isolated user space where you can run your programs that you have written, eBPF programs that you have written. So what exactly this will do? Like whatever programs you have written, so you will be getting an isolated space to make this program run, so that there won't be direct communication between the kernel level and the programs that you have written. So there will be some kind of communication, but that will be in the background only for the part where it is necessary. But apart from that, there won't be any direct interaction between the kernel level and the eBPF programs that you have written. Then we have network interfaces, like whatever eBPF programs that you have written. So you can directly take all these programs and you can attach these to the network interfaces, so that you can get a more good view, like what exactly is happening with your network, like what's the performance we can say, how the network packets are getting filtered, like what's the traffic. So you can get a very good view when you are attaching your eBPF programs to your network interfaces. Then we have user space applications. So basically for communication with your eBPF programs and the networking that you're having. So these user space applications are also there. So these are the four most important components of eBPF program, eBPF architecture we are having. So this is the architecture. So you can see how all the components are here, and like this kind of takes some time to explain. So you can just take a photo if you are willing to. Okay. Okay. So next slide we have is what exactly is eBPF's role now as in terms. Is there any issue? Okay. So what's the role of eBPF's role in Kubernetes security and networking now? So we'll talk about networking first. So when we are like kind of dealing with Kubernetes, we can say, so in terms of networking, like we have to deal with lots of network packet forwarding, we can say, and we'll be having this clusters created based on your project requirement. You'll be creating multiple clusters into your Kubernetes environment. So kind of basically to perform the load balancing between these clusters creation, we can say, and to perform the efficient packet forwarding, and also like service discovery within the clusters. So in these kind of use cases or these kind of operations, eBPF plays a very important role. And talking about security, like whatever security policies you are having, like based on your requirement, like what kind of security you need to implement on your system. So based on that, you can go ahead and you can create multiple policies, and you can attach all those policies directly into the kernel level only. So this is how again eBPF is playing very important role in Kubernetes security. Then we have observability. So if you want real-time monitoring of your system's performance, we can say, like how exactly the traffic is coming, and you need to take a real-time view of all the incoming traffic, we can say, and the monitoring work, like whatever metrics are there of your system. So these all things you can take a view in real time. So this is how eBPF is also important when we are planning to go see observability in terms of Kubernetes. So what are the challenges now? So even if suppose a person is a beginner or XYZ person is having some experience and they are just trying to learn eBPF, we can say. So first challenge can be steep learning curve. So if eBPF is not that complex, but it can be overwhelming for a beginner, we can say, because you'll have to understand so many things here. Like you'll have to understand what's the programming language in which we need to write the eBPF programs, we can say. And also you need to understand the architecture at very depth level. So that only then you can consider you'll be working with eBPF. So the learning curve is steep, because a person who is a developer or a system administrator, we can say, who is trying to understand eBPF, so that person need to understand so many things here. So that's why we can say the learning curve is steep. Then we have performance overhead of eBPF programs. The starting time that we need to just get started with the eBPF, that's gonna take some time, the starting time, and the memory that has been consumed by the kernel, we can say. So these both things will add to the performance overhead. And we have security considerations for eBPF programs. So again, like based on your requirement, you will have to take care of all the security considerations too, like multiple based on different scenarios. You'll have to go and write different security policies, we can say. So this is another challenge, we can say, like access control and security is there. Then limited documentation and learning resource. So even I have noticed that as compared to the other tools we have in the market, eBPF is having less documentation. Like I have barely found a good documentation which are basically trying to tell us about eBPF. Okay, so less documentation is there, but still there are some people who are kind of writing some blogs around it. So like if you really want, then you can connect with me on LinkedIn. I can share some amazing blogs around eBPF later on. So the next part we have is best practices. So what are the best practices that a person should follow if they are dealing with eBPF? So first one is utilizing existing frameworks. So whatever various multiple frameworks that we are having, so making use of all these frameworks is always a good choice, we can say, because there won't be any kind of another security issue, we can say, because already if they are there and they are already like people are using it, so it's always a good practice to make use of the things which are available. Then we have optimizing eBPF programs. So of course, like suppose if you are writing a eBPF program for your use case, so if possible, just try to optimize that program as much as possible, because if you're having less program, then definitely the complexity level is gonna decrease. Then we have implementing security controls and sandboxing. So again, like sandbox mechanism is there, like you can create a isolated user space for your program to run. So that is again gonna be a best practice, we can say. Then testing eBPF programs thoroughly, like before putting your eBPF program directly into the deployment, like creating an isolated users page, creating a sandbox environment, and testing your program there first before pushing that into the deployment. So this is another best practice, we can say. Then we have keeping your eBPF programs up to date. So again, like you'll have to make sure that if you have written some programs but some time has passed, so you'll have to make sure if there are some updations which are happening, so your program should be up to date with all these updations. So you need to take care of all these things. So these are the best practices that one should follow. So from here onwards, Prithvi will take care. Okay.
Thank you so much. So now that we know what eBPF is and what it does, so anyone have used tools that work on eBPF? Anyone? Okay, I just see a few hands. But there is one tool, I'm telling you, everyone here at least once in their life have used a tool that works on this BPF concept. That is TCP-dump. So TCP-dump is a Linux command line that it displays TCP or other packets that is flowing through a network. There is a very interesting comparison that I like to share with you all. So now remember how the websites used to look like 20 years back? It just had a text, image, and basically did nothing. And then came JavaScript, along with its fancy libraries and framework. It completely changed the way of designing a web application. So what exactly happened? It made the website more interactive by adding custom buttons, images and animations, and a lot more. So just to be specific, it made the website more dynamic. This is exactly what eBPF is doing to Linux kernel. So basically kernels are very stable, static. Even a small change will take years to get implemented. But eBPF, it changes the way the kernel behaves by injecting custom programs that allows us to see all these syscalls, network traffic flowing through the network. So we have been using the word syscall for a very long time, but what exactly is that? So syscall is the way in which application or process in user space communicates with the Linux kernel. So there are many tools in market to see to analyze the syscalls, and one such tool is called strace. So strace displays the list of syscalls generated by a process. So here you can see a small simple command who am I is giving me these syscalls, and if you would like to filter out these syscalls based on needs, then it can be done using a simple seccomp profile, but that is again a different concept. Okay, so enough of all the talking, let us jump directly to the demo. So today's demo is going to be on a very interesting topic that uses this eBPF technology. So it is a tool called Inspector Gadget, which is a CNCF project that basically does many stuff in terms of networking and security. So I hope most of you have used network policies, right? So has anyone faced difficulties while writing a network policy file? Show of hands. I just have 1, 2, 3. Okay. So now you can think network policy is a very simple concept, right? But I'm telling you, it is a very tedious process if you have lots of namespaces or pods. For example, if I'm adding a new namespace, then I have to go and configure the network policy file for all the namespaces and then change the ingress or egress traffic. So it is a very complicated process. But this tool here, Inspector Gadget, it is here to make our lives easier in those scenarios. So how does it do that? It monitors a certain namespace for ingress or egress traffic, and then based on the result, it is going to generate us a policy file automatically. Again, I'll just stop talking and we'll just directly go to the demo. Okay, so for this demo, I got a Kubernetes cluster from Azure. As you can see, there is no setup, just the default pods in kube system namespace. So Inspector Gadget requires us to install a special CLI tool called kubectl gadget. There are many ways to install. We are using a utility called crew here for this purpose. If you have SSH access to nodes, then you can also use a different CLI called IG. But just to make the demo simple, I'll just use a kubectl gadget command. So now you can see it is installing me a bunch of Kubernetes object, service account, role and role binding to interact with the API server. So Inspector Gadget is installed as a daemon set in gadget namespace. Since this is a single node cluster, we have only one pod. So let us take a few seconds to understand what exactly this CLI does. So it has multiple commands. I'll just explain a very few. So it has this trace command that will generate us a report based on specific events like out of memory killed or pod restart or any kind of TCP activity. And then we have got snapshot option that will list all the running processes in all the pods in a specific namespace. The one which we are going to see is called advise, that will advise us on a specific network policy that we can use for our namespace. So for this demo, I'll create two namespaces. One is called DevOps Days and one is called Kerala. And then I'm installing Nginx web server in both of these namespaces and also a cluster IP service to expose them internally. So now I'll open a new tab and then I will run the inspector gadget command. So I'm telling kubectl gadget to advise me on a network policy. It's not visible. I'm sorry, I'm not able to fast forward when it is in presentation mode. So I'll just explain what is happening. I'm telling the inspector gadget, advise me on a network policy file in DevOps days namespace, and then print all the output in network trace.log file. So once this is done, this process will run in the backend, and it will look for all the events happening in DevOps days namespace. So let us try to generate a simple request from Kela namespace that will act as an ingress, and then we'll see if inspector gadget is able to catch that. So for this, I will exec into the Nginx pod in Kela namespace, and then we'll do a simple curl command and then reach out to the DevOps days pod. So I'm doing a curl to the Nginx pod in DevOps days namespace. So this will act as an ingress traffic to that pod. And immediately that event will be captured in that file. So when we take a look at this file, it has some output, but it doesn't make sense, right? We don't need that in this format. We can also see this in the JSON format, but still we can see some information on pod IP, etc. But we want in a proper network policy YAML file. So there's a command for that. I'll do kubectl gadget, and then advise me again on network policy, and then generate me a report based on this input file. And then I'm redirecting that output to the network policy.yaml file. We'll just take a look at what we have in that file. So now it has given me this network policy file. So there was no manual intervention here. It was completely automatic. So there is this kubectl gadget running in that namespace, and then it is monitoring for all the events happening. Based on the event, it has given me this YAML file. And just some special effects to add that it is working. So this is for ingress, but what about egress? So now we'll also check if inspector gadget can catch that egress traffic. So I will do at exec into DevOps days pod, and then we'll generate a egress traffic to the other pod. Same process. I'll just do a simple curl command to the other pod. And then I'll again regenerate the network policy YAML file. Some of these events have been recorded in that log file. I'm using the CLI command again, kubectl gadget, to advise me on network policy, and then redirecting that output to the policy file. And in Malayalam we call adipoli, right? It works like a charm. Again, it has given me ingress and egress traffic, again with no manual intervention. It was completely automatic. So there is this inspector gadget again running on backend, looking for all the events happening based on ingress and egress traffic. So that's all for this demo. And this is the magic of eBPF. So it will allow us to run, to check for all the events happening at the kernel level, and then based on that we can add our own custom programs. So inspector gadget is one such tool. There are many such tools in the market. Just to name a few, we have got famous Cilium and Hubble. It is an open source tool that is used for service discovery, observability, and security. And then there's this popular Falco that is used to generate as logs based on events, such as if someone tries to execute a cell into the container, we can check that. And then we have got Bumblebee, and this is not the Bumble that we use in our mobile. This is open source tool that allows us to generate our own PPF program. So thank you for listening to our talk. If you feel like connecting with us, please use this QR code. Thank you. Any questions? Does anyone have? Okay, we got one question there. Yeah.
Since we couldn't see that demo, can you show the network policy?
Same?
Same network policy there in your shell.
Sorry.
See the demo actually.
Because if I'm in the presentation mode, I'm not able to fast forward, but I'll connect with you afterwards. We can discuss that. There was one more question there.
Yeah, hey, thanks for the talk. You just mentioned that eBPF has a steep learning curve. So do you have any recommendations of like how we should go about getting started?
If you want to get started with eBPF, and again, if you are a developer, then I would highly recommend you to take a look at the PCC framework that Python has. That will allow us to write our own custom eBPF programs. Or you could just go with, you could start using Cilium and Hubble. It is very easy to use, and it also uses this eBPF technology. Thank you.